Good morning, Year 12s. Today we are looking at the final bit of Chapter 6, which is looking at an unknown n. So if we look at this example, it talks about a door-to-door canvasser tries to persuade people to buy double glazing. The probability that he is successful is 0.05. We're being told that we need to find the probability that he has at least 2 successive out of the first 10 houses that he canvasses. Okay, now first of all we need to be able to see whether this will justify us using the binomial distribution. Now if we remember, there are 4 conditions where we can justify us using binomial. Number 1 is fixed number of trials, which is 10, fixed probability of success, which is 0.05, the trials being independent of each other, and having only 2 outcomes. Either people buy double glazing or they don't. So we can say X is the number of people who are persuaded to buy double glazing. This is our test statistic, and we say we can use this to estimate. We can use binomial distribution, where n is 10 and probability of success is 0.05. Now we need to find probability that x is greater than or equal to 2. We know that the calculator and the tables don't give us the probabilities of greater than or equal to, they give us less than or equal to, because they are done cumulatively in ascending order. So we do 1 minus the probability that x is less than or equal to 1. Now using our calculators, we can go to binomial. That's a bit hard to see, isn't it? If we go to binomial CD, we go to the variable mode, we put x as 1, n as 10, and p as 0.05. So 1 minus 0.91386 ... Now I've always said this, have another calculator ready, because you can easily use that to do the 1 minus probabilities. So the probability that he gets at least 2 successive out of 10 is 0.08614. Always give it to at least 3 significant figures. So in this case I've given it to 4. That means he's got about 8.6% chance. Okay. Now part B is where it gets interesting. Part B says calculate the least number of houses that he must canvass in order that the probability of his getting at least 1 success exceeds 0.99. Now we're trying to find how many houses does he go around asking, canvassing, so that the probability of him getting at least 1 success is greater than 99%. So if we write down the notation in this case, it's probability of him getting at least 1 success exceeds 0.99. Now this, again, we would have to rewrite as 1 minus. So it becomes 1 minus the probability that x is less than or equal to 0, which is the same as probability x is equal to 0. Now if we rewrite this again, we want to get probability on its own, so we're going to move that to the right hand side. So 1 is greater than 0.99 plus the probability x is equal to 0. I'm going to move 0.99 to the other side. 1 take away 0.99 equals the probability x is equal to 0. Now this means the probability that x is equal to 0 is less than 0.01. Now we looked at these questions in our previous lesson where we were doing trial and error in our list mode to see at which point the probability was less than 0.01. The issue here is we can't do trial and error because we don't know n. So if we were to get our calculator out, well, we can't really put what n is in there because we don't know how many hazards he has to canvass. Now at this point, you are expected to rewrite this in binomial. So this means out of n number of things, you're trying to really have combinations for 0. The probability of success, which is 0.05, is to the power of n. The probability of failure, which is 0.95, is to the power of n minus 0. Oh, sorry, this one is 0. And this one is n minus 0, which is just n. So the probability of success is raised to the number of times the success is. Probability of failure is raised to the amount of times. So that's raised to the 0, that's raised to the n, is less than 0.01. Now, we know that NCR with any number and 0 is just 1. Anything to the power of 0 is also 1. So it's 1 times 1 times 0.95 to the power of n is less than 0.01. Now here you have two options, year 12s. You could use trial and error, and you could sub in different values and see what value of n gets you a value that's less than 0.01, or we could use logs. So to bring the power of an unknown back to the base, we log both sides. So log 0.95 to the n is less than log 0.01. In laws of logs, if the unknown is in the power, it can be brought forward to become a coefficient. Becomes n log 0.95 less than log 0.01. Now in this case we're going to divide through by log 0.95 to get n on its own. Now here, whenever you divide by a log, it's best to check what number that gives you. Now I'd like you all to put log base 10. So in your calculator you may have a little base, and we are just dealing with base 10s here. So if you put log base 10 is 0.95 in your calculator, quickly do that for me. It comes out with a negative number. Now if we ever divide in an inequality by a negative number, what happens? The inequality flips, that's right. So that means n is greater than log base 10 of 0.01 over log base 10 of 0.95. We don't have to keep rewriting as log base 10. It's a known thing that if it's just log, then it's a log base 10. Now if we put that in our calculator, that comes out to n being greater than 89.78. That means he has to go around canvassing at least 90 houses for him to have a success in at least one customer to be exceeding 99%. Okay, I've uploaded assignment 4 on Google Classroom, and that has got a couple of questions in there to do with an unknown n. So this would be a really good way of checking whether you have understood this. Any questions, as ever, please don't hesitate to email me. I hope you're all taking care of yourselves. Stay safe, take care, bye.